Graphing reciprocals of quadratic functions, part 1. So first thing to know is that there's an asymptote for every x-intercept. Make a note of that on your page. So first off, if you have no intercepts, you will have no asymptotes. So the graph of your function will look like this. You'll have a line going towards the x-axis, a bump where your graph vertex is, and it'll keep going. Same thing if it's on the bottom side, it opens down towards the x-axis, bump for your vertex, and keep going. If you have one x-intercept, you will have a vertical asymptote at the vertex, and your graph will go towards the vertex and towards the x-axis infinitely. And it's the same direction as the way your graph opens. So same thing on the bottom. If it opens down and it's negative, you have a function that opens down. If you have two x-intercepts, you will have two vertical asymptotes at the x-intercepts. Your graph will reflect the opposite way of your vertex, and on the sides will stay on the same side that they are on above the x-axis. So if it's down, it's the same thing with blue asymptotes. Reflect your graph up, and the sides are on the bottom. So that is the way a two-asymptote quadratic function looks. So you have three sections. Okay, when you are graphing, when you know that you have no x-intercepts, and we know this because our bottom cannot factor, you can always do this by sketching your graph first. So we're going to sketch the graph y equals negative x squared minus 1. So we know our vertex would be 0 and 1, negative 1, and it opens down. And we know there's no intercepts because if it's below the x-axis and it opens down, it won't cross the x-axis. So no asymptotes. So plot your vertex. You have a negative a, so you go over 1, down 1. So this would be your original function. Now, to find the graph of the reciprocal, we're just going to do a quick table of values. And this is for y equals 1 over negative x squared minus 1. And we're going to do it for things that are close to our vertex. So we're going to do negative 1, 0, and positive 1. When you plug this into your equation, your y should get negative 0.5. The reciprocal of negative 1 stays the same because it is an invariant point. So the vertex in this equation is our invariant point. And 1 is negative 0.5. So we're going to graph this. So we have a point here, a point here, and a point here. So we know that the horizontal asymptote is our x-axis. So we connect the lines and go towards the x-axis. So there's the graph of our reciprocal quadratic function. The domain of this equation will be that x is an element of all the real numbers because it can be anything. And the range we know would be in between 0 and 1. So we know 0 is less than y, which is less than or equal to 1, because we know it can be this point for all the real numbers. So there's our range. For the next function, we want to find our vertical asymptotes. And we know that we have one when the bottom is equal to 0, so when x minus 2 equals 0, so when x equals 2. So we have one vertical asymptote, so we should know the kind of shape our graph has. We are going to graph the original function y equals negative x minus 2 squared. So we know our vertex is at negative 2 and 0, and it opens down. So negative 2 and 0 is our vertex. It opens down with a normal stretch. So it looks something like this. We know because of this that we have a vertical asymptote at negative 2, so we're going to draw that in with a broken line. And because it opens down, we know that our graph is going to be in our bottom two quadrants. So we want to find our invariant points. So if you drew this correctly, you have an invariant point here and an invariant point here, except I drew it really sloppily. So the invariant points are at negative 1 and negative 1, and negative 3 and negative 1. There's no positive invariant points because it doesn't go above the x-axis. Another way you could solve to find your invariant points is to plug in a negative 1 and a positive 1 for your y, if you didn't originally graph the function. Now all we're going to do is we're going to draw towards our asymptotes, through our invariant points, and towards the horizontal asymptote. So there's the first one, and then you reflect and do the same thing on the other side. So the purple is the graph of our function. Our domain would be x is an element of the real numbers, except x cannot equal negative 2. And our range would be y is less than 0. It does not include 0 because it can't touch the x-axis for all the real numbers. So there's our domain and range. For this quadratic, we know we're going to have two vertical asymptotes when x minus 1 equals 0 and when x plus 1 equals 0. So at x equals 1, x equals negative 1. So let's just draw those in right now. So a broken line going through those x values. Now, if we wanted to sketch the original function, y equals negative x minus 1, x plus 1, we would know that they intersect here and here, and it opens down. And because we have a normal stretch, our vertex will be halfway in between these points, one up. So our normal function would look like this. Now that you have a picture of your normal function, we're going to figure out our invariant points. So when y is positive 1 and negative 1. So our invariant are at 0 and positive 1, negative 1.5 and negative 1, and 1.5 and negative 1. Another way that you could do this, of course, would be to solve for these points. But from our graph, it's close to about 1.5. It might be a little bit less at 1.25. Go from about what you see. From here, when you draw your function, you're going to go first to your vertex, and you're going to draw the opposite direction and reciprocate it up towards your asymptotes. And on the bottom, draw through your invariant points and towards your asymptotes. So there's the graph in purple of your reciprocal function. Your domain would be that x is an element of the real numbers, except it cannot equal negative 1 and positive 1. And now your range. You know that it has to be greater than or equal to 1, and that's supposed to be a y, or it can be less than 0 for all the real numbers. So y either has to be greater than or equal to 1 or less than 0.